So this is your homework number 1 solution. Okay? So your first problem, you have your f of x equals 3 minus 2x. And you are looking at the interval from negative 3 comma 1. So for letter A, you want to find your right Riemann sum, and we need an explicit formula. So for this, we need our delta x. Delta x will be, remember, b minus a. So this will be 1 minus negative 3 over n. So this is equal to 4 over n. Your x sub I star, since we are only interested in the right Riemann sum, we choose it to be x sub I. And x sub I, that's your A, that's negative 3 plus I delta x. Sorry, it's getting smaller. I think I should enlarge this guy here. Yeah, I think this one is better. But delta x here, it's 4 over n. So our x sub I star will be negative 3 plus 4I over n. Okay? And then, therefore, our A sub I, the area of the ith rectangle, this is f of x sub I star times delta x. But this one will just replace the x with the x sub I star, which is this guy. So we have 3 minus 2 times negative 3 plus 4I over n. And then this guy here, it's being multiplied to delta x. And delta x, it's 4 over n there. So let us simplify this. We have here 3. And then in here, you have minus 2 times minus 3. That's plus 6. And then minus 2 times 4I over n. That becomes minus 8I over n. And this guy here, it's being multiplied to 4 over n. So if we simplify this, we have 3 plus 6, that's 9. 9 times 4, that's 36 over n. And then for this guy here, you have minus 8I over n times 4 over n. That's minus 32I over n squared. Okay? Then, what is now our Rn? Therefore, Rn, this is equal to the sum from I equals 1 up to n of f of xi star delta x. So this is the sum from I equals 1 up to n of 36 over n minus 32I over n squared. And then remember, 36 over n, it's constant relative to this I, to the index of the summation. So it can go out, okay? You will have 36 over n, summation of 1, okay? I from 1 up to n. And then the other guy here, similarly, 32 over n squared, that's just what? Constant relative to your index I, so it can go out again. So 32 over n squared, summation of I from 1 up to n. And then from here, I'll just recall summation of constants I from 1 up to n. This is just Cn. And summation of I from 1 up to n, this is n times n plus 1 over 2. So we use this. So for the first guy here, it's just 36 over n times n. Okay. Um, Let me do some adjustment in here so I will have some space. Okay, that should be fine. So for this, we have here 36 over n times n, then minus 32 over n squared. And then we have this. Let's simplify this into n squared plus n over 2. So if we simplify this further, we will have 36 minus 32 over 2, that's 16. And then you have your n squared over n squared, they will cancel out. Then minus 16 over n. So if you simplify further, Rn, this is just 20 minus 16 over n. So this is the one I need. That's for letter A. For letter B, so for letter B, we need Rn. We need the limit of Rn. Okay? So we want the integral from -3 to 1 of f of x dx. And it is said here or in the problem that we just need to calculate the limit of Rn. So this is the limit of Rn as n approaches plus infinity. So this is simply limit as n approaches infinity of 20 minus 16 over n. And again, 16 over n here as n approaches infinity, that will go to 0. So we will get 20 in here. Okay? Question. So for number 2, you need antiderivative of antiderivative g of x of your small g of x. This is what? Tangent x plus cotangent squared x over cosine x, such that g of pi over 4, this is equal to what? So in here at this point of the lecture, we don't have the indefinite integrals. Okay, so we need a function capital G such that the derivative of this capital G, that's equal to small g of x. So to do that, we start with your g of x. Let's write this g of x. So we rewrite this as tangent of x over cosine of x plus cotangent squared of x over cosine of x. What's tangent? Tangent, it's sine over cosine. So we can rewrite this as sine x over cosine squared of x. No, for this guy, instead of rewriting this in terms of sine and cosine, um, we have tangent of x times 1 over cosine of x. We can rewrite this, therefore, as tangent of x secant of x. That's for the first guy here. Plus, for the second guy here, cotangent squared x, we rewrite it as cosine squared x over sine squared x. And you still have this 1 over cosine x. So, of course, you can cancel this and this. So, this will be simplified into tangent x secant x plus. You can rewrite this guy here as cosine of x sine of x times 1 over sine of x. And therefore, your small g of x is tangent of x secant of x plus cotangent of x cosecant of x. And now we can think of some function or whose derivative is equal to this. And for that, we can just take g of x, capital G of x. We can take this as secant of x minus cosecant of x plus the arbitrary constant c. Okay? So observe g prime of x. This is equal to the derivative of secant of x. That's secant of x tangent of x minus the derivative of cosecant of x. That's negative cosecant of x cotangent of x. Of course, derivative of constant, that's just 0. And if you simplify this, this is precisely small g of x. So this means we have the general antiderivative. Okay? So, if g of pi over 4, this is equal to 1, then you have 1 equals g of pi over 4. This is what? Secant of pi over 4 minus cosecant of pi over 4 plus c. If you remember this, secant of pi over 4, that's just square root of 2. Cosecant of pi over 4, again, that's square root of 2. Okay? And this guy here, you have the plus c, which means that c equals 1. Okay? Therefore, the desired function is, therefore, the required function, required antiderivative is g of x equals secant of x minus cosecant of x. So let me adjust this. So g of x minus equals secant of x minus cosecant of x plus 1. So this is the required function. Okay?